Good morning, everyone, and welcome. As introduced, my name is Jason Yates, and I am the Technical Services Manager here at Riello UPS Limited. The purpose of the training today is obviously to ask a question and hopefully answer a critical question in that, can today's data center UPS systems effectively help make new and existing data centers more sustainable? Well, we're all aware that the data center industry is one of the fastest growing and transforming industries of the last decade. We've seen data centers obviously are the backbone of modern society, always on digital connectivity, data storage and processing, and high-speed internet are all integral to obviously our modern way of life. Now, this seemingly unstoppable shift towards smart technologies and obviously the Internet of Things guarantees the global demand for data and, of course, the vast amounts of energy required to safely store and process it. Now, as a result of these demands, the data center industry is under the spotlight, having become very power hungry, meaning that sustainability is not a choice, it's our responsibility. Now, if we just consider the last decade, server rack power density has increased fivefold. We now have high power immersive cooling systems, as we've just been seeing, and data centers have grown from 5 megawatts up to hyperscale levels where it's not uncommon to have facilities more than 100 megawatts. So the question we need to ask is just how much energy do data centers consume globally, and what is the forecast for consumption over the coming years? Well, the annual electricity report from the International Energy Agency says that data centers are significant drivers of growth in power demand across many regions. Now, after globally consuming an estimated 460 terawatt hours in 2022, it's estimated that the data center power usage is set to double by 2026, meaning that it could reach more than 1,000 terawatt hours in a worst case scenario. Now, to put this all into perspective, this demand is roughly equivalent to the power consumption of Japan. Now, we can all find numerous articles and debates on sustainability challenges, but according to some authors, sustainability is no longer a choice, but a forced direction for our consumption and social responsibilities. This issue has obviously influenced even global political strategies. We've got initiatives coming from the UN with COP. At an EU level, we have the European Green Deal. And of course, we've got initiatives from local governments. But all of them have a common goal in mind, which is obviously to set targets for reducing global temperature and the cutting of obviously the overall CO2 emissions. Now, based on these factors, it is clear that the future of the data center lies between balancing innovation whilst meeting the needs for sustainability. Now, as a UPS manufacturer, the question we asked was, how could we actually help the data center industry drive the transformations to become more sustainable? Obviously, without the need to compromise on the all-important reliability. Well, when we started to develop the UPS that I'm about to share with you, we meticulously collected information from the data center industry to understand the trends and obviously the major concerns of the operators. Now, one common point contained within all of the different surveys, reports, and comments was related to the huge impact of the energy costs of actually running the data center. Now, as you can see from this TCO breakdown, typically 60% is related to the operational energy costs, whilst 30% relates to the operational and maintenance. And so as a UPS manufacturer, it was obviously these two key areas that we focused on, because obviously we could influence these areas when we started to develop the UPS that we've developed. Now, when we talk about operational energy, the most critical figure within any UPS is obviously the overall system efficiency, as it affects so many different areas. By definition, the UPS's efficiency is defined as the active power measured at the input versus the active power measured at the output, which is typically measured in watts, kilowatts, or even megawatts, depending on the size of the system. Now, the difference between the input and output power is effectively lost energy, which is obviously typically wasted. And in most cases, this wasted energy is converted to heat, which generally needs to be removed and or be cooled, which again, obviously requires more energy. So it's a vicious circle. Now, basically, the greater the energy loss, the lower the efficiency, the higher the costs. Now, every UPS manufacturer ultimately strives to achieve 100% efficiency. However, sadly, due to the current technology and, of course, laws of physics, this is simply not possible at present, albeit through advanced UPS design and the very latest in component technology. We as a manufacturer are getting close, along with many others. Now, the question we need to ask is, why is a modern UPS not already 100% efficiency? Well, due to the way in which the online dual conversion UPS system operates, obviously losses are inevitable. And basically, the UPS functions by making two power conversions, hence the name dual conversion. Now, the first conversion is the conversion of the incoming AC voltage into DC voltage, and the second conversion is the conversion of the newly created DC voltage back into a clean and stable AC voltage in order to provide the power to the critical load. Now, the term online simply refers to the fact that the load is being permanently powered by the inverter. And basically, it is these power conversions that obviously cause the losses within the UPS and obviously the subsequent heat that is generated. But most importantly for the data center's resilience, the online dual conversion UPS is probably the most reliable source of power, obviously for the critical loads, especially when used in the various parallel redundant formats and so on. Now, the key requirements for any UPS system is obviously to provide the highest levels of efficiency without compromising on reliability. But don't be fooled, as some manufacturers do juggle these figures a little bit in order to exaggerate the final numbers. And so one thing that we always ask people to do is always check that the data being provided is obviously factual and that it meets the needs of your specific application. Now, on this note, shameless sales pitch now, I'm afraid, I would like to introduce to you the Multi-Power 2. Now, Multi-Power 2 is effectively an ultra-high efficient modular UPS system. Now, like all modular UPS, the key building block is the actual power module itself, and the Multi-Power 2 is no different. It is effectively built using a 67 kilowatt power module, which utilizes the very latest in silicon carbide technology. Now, this state-of-the-art module is obviously coupled with three main power cabinets. Now, the ones that we have available, these are the 5 to 600 kilowatt cabinet, the 1 to 1.25 megawatt cabinet, and the 1.3 to 1.6 megawatt cabinet. And Multi-Power 2 can obviously also be expanded up to 6.4 megawatts by obviously paralleling multiple cabinets together. Now, like all modular solutions, the cabinets are populated with power modules. However, unlike some other systems, these modules are all truly hot swappable, and the cabinets obviously have spare capacity for redundant modules. And all cabinets come as standard with a fully rated centralized static bypass system. Now, the Multi-Power 2 has been specifically designed with flexibility in mind, making it compatible with most infrastructure's environments. The cabinets themselves can be basically supplied with or without power switches, which obviously can help improve the overall system efficiency by approximately 0.1%. Let's face it, every little helps. They can also house internal backfeed contactors for additional safety and resilience. Furthermore to this, they can be supplied with top or rear airflow for flexible positioning. They can be connected via cables or bus bars. They can operate with lithium batteries. All systems have multi-mode operation, so they can be operating in online, eco, smart, active, frequency conversion, saying but a few. They can be integrated into smart grids for peak shaving, stabilization, off the grid, and so on. And they can be specifically configured for, obviously, bespoke applications. Now, so the question we need to ask is, what actually makes the Multi-Power 2 sustainable? Well, it all starts with the power module, which has been specifically designed with sustainability in mind. Now, the module itself can achieve an efficiency of up to 98.1%, so the heat loss is minimized. It has a high power conversion density at 6-7 kilowatts in just 3 use, so the modules are compact. It can operate permanently within a 40-degree ambient without any power derating. It has a very high DC to AC conversion efficiency, so no battery energy is being wasted. And finally, it has an efficiency control mode, which can dynamically adjust the number of active modules in order to maintain a constant high level of efficiency throughout all modes of operation. Now, If we take a closer look at the actual efficiency curve, we can see that between the load levels of 23 to 47%, the system operates at an efficiency greater than 98%. Then as we widen this load level between 15 to 80%, the system still continues to operate at an efficiency greater than 97.5. And obviously between the load levels of 10 to 100%, the system is still maintaining an efficiency greater than 97%. Now, in addition to this, the efficiency control mode, as mentioned earlier, can help improve the overall efficiency by 0.5% at much lower load levels. Now, a very important point in relation to the efficiency curve that you see here is that all of the figures shown are with the UPS operating in true online mode. These are not average figures as used by some manufacturers. Now, when we say the average figure, typically what some manufacturers will do, they will basically use the average efficiency, which is effectively a mix of both online and eco modes over a fixed period of time. So it's not really a true representation of most real world conditions. I mean, let's be honest, most operators are going to be running their online dual conversion UPS systems in online mode for maximum protection. And so one thing we always say to people is always make sure that these the figures being shown are correct and they actually suit your application in most cases, which is going to be online double conversion. Now, the main change which has enabled us to produce a UPS with such high efficiency is the implementation of silicon carbide. Now, the table here compares a typical silicon device versus a silicon carbide device and highlights the key differences. Now, from this, we can see that the overall chip area is reduced by approximately 80%. So the silicon carbide devices are much smaller. The conduction heat losses are very similar. In fact, silicon carbide is slightly higher. Now, the switching losses is where the main gains are achieved, where we see a drop of 75%. And when we add all these figures up, we see an overall and combined reduction in heat loss of around about 48%. And finally, one of the main benefits of silicon carbide is that its performance is consistent across the full load range. And so it is ideal for UPS applications and especially beneficial for the likes of the up-and-coming AI load profiles to maintain a very high level of efficiency as the load demand is permanently changing. Now, what other benefits does it provide? Well, the reduced losses mean smaller heat sinks, resulting in a compact design. They have excellent thermal management, so the devices are extremely stable. The overall component stress is reduced, meaning increased reliability. It provides a high power density, resulting in high power levels from very small devices. And most importantly, silicon carbide is a proven and reliable technology, which is used extensively throughout the EV and industrial markets. Whereas you can appreciate the operational conditions can be extremely harsh, especially compared to a UPS system's operation. Now, there are further benefits. The high efficiency means reduced wasted heat, resulting in smaller cooling plant on site. The high DC to AC conversion efficiency can result in much smaller batteries in terms of volume and capacity. The systems operate with long life capacitors, ensuring a maintenance-free lifespan. Now, traditional UPS will have its capacitors changed around years 5 to 7, but in this case, they will operate for a full 15 years of operation without being changed. The systems can provide a high mean time between failure, a low mean time to repair, and are obviously very easy to use, which means reduced engineers intervention. And basically, all of these key points result in significant CapEx and OpEx savings, but most importantly, obviously, lower the environmental impacts. Now, we cannot look at the gains, obviously, without looking at the potential financial and CO2 savings. So, as an example, if we deployed a 98% efficient UPS instead of a high efficient 96% efficient UPS, and only looked at the UPS heat loss and the cooling power requirements, if we look at using a typical 3.2 megawatt UPS system comprising of two 1.6 megawatt blocks with a load of 3.2 megawatts, we can see that based on a calculation criteria, so there's a lot of numbers here, so here goes, a cost per kilowatt hour of 15 pence, a cooling coefficient of performance of 2.5, a CO2 per kilowatt hour of 0.233 kgs, and a climate control levy of 0.775 pence per kilowatt hour, an annual decrease in electricity CO2 production of 3%, an electricity cost inflation of 4%. I've not included for any reactive power charges or any maintenance costs. And at this load level, the expected efficiency is going to be around about 97.5 for the high efficiency machine, and around about 95.5 for the lower efficiency machine. I hope everybody got all those numbers. So based on those numbers, the system of that type would typically provide an annual saving of around about 840,000 kilowatt hours per year, which obviously equates to a saving of around £133,000 per year. And over 15 years, this results in a saving of over £2.6 million. Now, in terms of the environment, over 196 tons of CO2 are saved per year. And over 15 years, this adds up to over 2,400 tons of CO2 saved. And so, as you can appreciate, the savings are significant, and obviously they simply cannot be ignored. Now, it goes without saying, obviously, that silicon carbide may appear to be the miracle cure, but there is obviously a key point that I need to cover. Now, silicon carbide devices need approximately 4 to 6 times more energy to manufacture. Thus, 4 to 6 times more CO2 is produced, which obviously also increases their production costs. Thankfully, however, we can offset a lot of these issues in that the silicon carbide components used only form a small portion of the power module's construction, and so the impact of this is minimal. In addition, the increase in the CO2 and costs are partially offset due to the module's simplified design and clean layout, which makes it quick and easy to manufacture. Furthermore, the remaining CO2 and the costs are quickly offset by the energy levels saved during the system's operation. And finally, ST Microelectronics, the largest producer of silicon carbide components and the supplier to Riello UPS for that matter, are committed to being totally carbon neutral by 2027. So in conclusion to this, silicon carbide is not perfect, but obviously it's heading in the right direction. And obviously things will continue to improve as volumes increase, more and more component types are developed, and obviously higher power ratings are obviously brought to the market. Now, one of the key questions about sustainability, and one of the key questions that data center operators want to ask is, does the sustainability come at a cost of reliability? Well, let's take a brief look at the design and the technology implemented to ensure the reliability. Now, the power module, which you can see on the screen there, is constructed with only a few connection cables, which basically removes any potential points of failure. The overall component count is low, which obviously statistically reduces the potential for component breakdown. And the modules use the very latest in high-speed processors and advanced diagnostics. In addition to this, the modules use speed control fans to minimize wear and tear, obviously along with a fan failure detection. They have been designed specifically to enable the fans to be easily changed. As with all UPS systems, the fans will typically operate on an average of 7 to 9 years, at which point they'd have to be changed. But depending on the conditions and load, these fans can actually last for the full 15 years, thus reducing component wastage and servicing costs. The module is mechanically and electronically segregated, preventing fault propagation between modules. The control firmware and operational parameters are automatically aligned, meaning that should a module be added or be replaced, it is quick and simple, but most importantly, it significantly minimizes any risks. A module can easily be swapped in under 5 minutes, so upscaling or repairing the system can be performed by on-site teams, and obviously which removes the need for specialized engineers. And finally, the systems obviously have a full automated health check-in with instant condition reporting, along with a dynamic control protocol, which obviously doesn't have any form of central controller. So obviously reliability is extremely high. Now, in developing the module, we've even considered the environment. Now, each module is provided with humidity and temperature sensing. They have input air temperature monitoring. They have capacitor temperature monitoring. They have PFC and inverter temperature sensors per phase. Basically, the module builds a full environmental and thermal map for monitoring and full predictive maintenance. Now, of course, no modular system is complete without the cabinet, which obviously contains several key features. There are parallel cards for cabinet paralleling, which is used via a closed-loop communications bus, which can obviously utilize either a Cat6 cable or optical fiber. There are no dedicated power supplies, and so all components have been optimized. The system utilizes a high-speed, true redundant dual communications bus, and obviously all modules are mechanically and electronically interlocked for obviously safety and security. In addition to this, the front doors are all fitted with air filters, obviously, which prevents dust and dirt ingress. Each cabinet is fitted with air pressure sensors so that we can monitor the contamination levels of the air filters which are fitted to the doors. The rear of the cabinets are fitted with fire detection sensors adjacent to the main connection assemblies. And the static bypass module, which is obviously critical to the system, is fully accessible and obviously sized for 105% continuous overload. Now, if we return back to where we all started and ask the same question, in that, can today's data center UPS systems help make new and existing data centers more sustainable? Well, we truly believe that the answer is yes. I mean, in this case, we've combined the untapped potential of silicon carbide semiconductors, whilst obviously pushing the boundaries of UPS design and manufacturing to the next level. Now, Multipower 2 is a result of this process. It's basically a modern modular UPS that delivers basically data centers the scalability, resilience, and durability they require to handle today's increasingly complex load profiles. Now, and it does all this at obviously previously unseen levels of efficiency in order to provide the energy, costs, and carbon savings that will help data center industry become more sustainable, which is obviously the key point. Now, this is just a small glimpse of what a Multipower 2 system is truly capable of and where we're going in the direction of ultra high efficiency modular UPS for increased sustainability and reliability. And so in this case, if you'd like to know more, obviously, or if you want us to review a particular efficiency or sustainability application, then obviously do come and talk to us. Many thanks for your time, and if you have any questions, and I will gladly take those now.
Thanks so much, Jason. I do just have a couple of questions I'm going to skim through quickly if I can squeeze them in. I'll try. The first one's quite long, so I'll try to read slowly. I know I read very quickly. We're not currently in the market for a UPS, but we're curious as to how the technology can further evolve for when we're due a replacement. Sustainability is really important to us, and we're curious about new technologies. We've heard about hydrogen, flywheel, and solid-state batteries. Where do you see the industry going?
Oh, yes. I think we're a bit of a crossroads at the moment, to be honest with you. In terms of the technology, there are some, if you look at the UPS, first of all, there are some newer materials coming through, and there are some newer developments in the pipeline, which unfortunately I can't talk about. But obviously a lot of big companies are developing and pushing silicon carbide and some newer materials with even higher efficiency. So in terms of the technology, I mean, in terms of the reliability and so on, that's just getting better day by day. The systems are becoming more simpler internally, so they're becoming more reliable. In terms of the surrounding technology, in terms of the storage mechanism, whether it be hydrogen, lithium, it's a difficult one at the moment. We're finding most people are sticking at the moment with traditional lead, to be honest with you, or going pure lead. There's a lot of people moving through the lithium, but again, there's a lot of fear around the lithium in terms of, the potential for fires. But again, a lot more lithium manufacturers are starting to now, inbuild their systems with fire retention systems anyway. So again, this is getting better. In terms of hydrogen is a very interesting one, to be honest with you. And I do believe that people are making a lot of developments in this area. But again, we are seeing in terms of flywheels, I think I'm not. We've seen the flywheels drop off, to be honest with you, in terms of what we see in the marketplace now. The main factors going forward, hydrogen is most definitely one. Obviously, pure lead is one that's coming through. And it's then the lithium or any alternative to lithium is where it's going. But it's the lithium is quite a hard sell, to be honest with you, especially from the fire perspective. But more and more people are taking it, and it's getting more and more stable. So
there's a little bit of watch this space for future developments.
We're a bit of it's a bit of a crossroads at the moment, to be honest with you, like I say. So
thank you. In terms of batteries for our UPS, we're currently using VRLA, which is recyclable, whereas lithium-ion isn't as easy to recycle at the moment. How do we overcome that? Of course, a lithium battery lasts longer, but it doesn't feel very sustainable.
No, it doesn't. I mean, obviously lithium does last longer, but again, there are some common misconceptions. Obviously, lithium does get affected by temperature. It does have an impact, a lifespan. Albeit it does have a longer lifespan, but when people are obviously talking about 20, 25-year lifespans of lithium, You've got to be mindful as well. There's obviously a lot of electronics in the lithium battery system, so you've got to look at the lifespan of that as well. It's not just about the lithium itself.
Yeah.
In terms of the recyclability, yeah, at the moment that's a bit of a grey area. Its recyclability is quite poor at the moment. I'm sure the likes of Tesla are probably doing quite significant strides in that area. I'll be honest with you. I'll be honest with you, I'm not entirely sure where they're up to with that. But things have to be done, to be honest with you, to make lithium viable, let's be honest.
Yeah,
so
thank you. And then just one final question before I let you off the hook. What is the power module MTBF?
So the MTBF of the power module itself typically sits around about 450,000 hours per module. But obviously that then obviously sees when you've got some of the cabinets, you can have M+6. So you can actually have up to 6 spare modules at 1.6 megawatts. So you've got a huge amount of redundancy in the cabinets themselves. And then obviously if you combine that with an A and a B streaming, you know, you're in terms of the nines levels, it's going crazy high levels. But obviously the module itself, likelihood of a failure of a module obviously doesn't affect the overall system, which is obviously the purpose of the modular solution. And you've got plenty of redundancy in the cabinets plus in the frame as well. So there's plenty of, when you look at the MTBF, we really should be looking at the total overall MTBF where you're in millions and millions of hours effectively. So yeah.
Okay, once again, thank you, Jason, for
No
taking
problem.
the time.
No
we
problem
always appreciate
whatsoever.
your insight. So thank you very much.
Problem.
Have a great day.
Thank you very much. And you take care.